Now let's get on to our session. Today we're talking software as a service, SaaS, a very hot topic as we all know. So I'd like to say thank you first to our friend at Vertex Ventures, Dominic Perry, for connecting us to our illustrious speakers today. Ori Rafael, CEO and co-founder at Upsolver, and Vishal Jain, CEO and co-founder at Valtix. And they'll be talking to you guys about the challenges and innovation in SaaS and sharing some examples and best practices from their experiences. Over to you, Ori.
Thank you. Thank you for hosting me. So I'm Ori, I'm the CEO of Upsolver. Today, the presentation I made is around architecture and around data architecture in the cloud, and a concept called the lakehouse that has been developing very fast in the last couple of years. And today I want to talk about that, about what kind of flavors you have to the lakehouse, what are the benefits, and how can you really get the most out of it, and also show some examples of customers that we implemented an open lakehouse, which will be the focus today. So a bit about myself. Aside from Upsolver, I've been in data pretty much my entire career, starting from Oracle to SQL Server to eventually to data integration. Most of that experience was in the Israeli intelligence, so definitely a lot of data and a lot of analysts there. And in Upsolver, so Upsolver, if I could describe it in very simple words, it's a visual interface based on SQL that lets you power a cloud lakehouse. It's not the cloud lakehouse on its own. It's part of an ecosystem, especially if we're talking about the cloud. Upsolver today is a mature service. It's been around since 2018. Today we are processing over 2 trillion events from customer data every day, all of that in the cloud. And we're working very tightly with Amazon, and actually Amazon have a service, probably many of you know it, called AWS Athena, which is Amazon Managed Presto. And today Upsolver is the only recommended partner for that use case, which ties very strongly to the lakehouse. So the agenda for today, start with talking about what we have today. So the cloud data warehouse, the cloud data lake, I think there are the more familiar options. Then I'll present what's an open cloud lakehouse and how is it different than the traditional approaches, and show 3 examples, each one from a real customer and how they built their architecture using a lakehouse. Okay, so first option, the data warehouse. When I started doing any kind of work, it was on Oracle database, later on an Oracle data warehouse. And I think that everyone agrees that the data warehouse is the easiest way to analyze data, mostly because it's SQL based. So SQL is the language of data. All data analysts, developers, even product managers, engineers, all of them can use SQL. I think that if at any point in time I would tell the army unit I was at, hey, let's drop the warehouse and do some code-based analytics with thousands of analytics users, probably I would be laughed out of the room. So it was clear to us that we need an SQL-based solution. Data warehouse was a good fit. But of course, when we wanted to do a new use case, we wanted to start doing something like machine learning or streaming or text search, the Oracle database wasn't built for that. And I think the reason I keep saying Oracle, although the header is cloud data warehouse, is because the data warehouse is still a data warehouse, and we can compare the two. And what I couldn't do with Oracle, I can still come and say, can I do it today with a more modern cloud data warehouse? So if all of my data was locked in Oracle, I couldn't really get it out. It was proprietary storage, proprietary metadata, Oracle's own access control mechanisms. So I think that the cloud data warehouse is similar to Oracle in that sense. So it's a great tool, but it locks you in, and probably it wouldn't solve all of your use case. But the ones that it does solve, it does very well because it's based on SQL. One more parameter that's usually very important is cost. So data warehouse is usually the most expensive way to analyze data. And if you're going to analyze your data from raw data all the way to analytics data using the data warehouse, you're going to pay the most amount of money for that option. So for example, if I'm doing data prep, if I choose to do it in the database, it's maybe more comfortable. Probably doing it in the data lake would be a much cheaper option. So from that, I'm moving to the cloud data lake, and the approach for a cloud data lake can still be SQL based, but everything that happens in the middle is not SQL based. That's usually something that you'll do with the Hadoop or Spark ecosystem. You will code in Java, in Scala, in Python, and eventually when data engineers are going to finish their job, there's going to be a table ready for analytics, and analysts will start their work from there. They will not get access to the raw data itself. So this solution, of course, is not as easy to use, and it doesn't provide the same analytics value as a data warehouse. I think data lakes have been often called data swamps for that reason, but it's a very cost-effective solution. You can run any scale, you decouple compute and storage, the cost itself for the compute is much cheaper, and you can connect any engine that you want. So today I'm working with one engine. Tomorrow I can take Elasticsearch for text search. I can take Spark for doing machine learning. I can work with Snowflake as my data warehouse. So I can work in all different ways, but I need to code everything. So I have easy and expensive versus hard and much more cost effective. And that brings us to the cloud lakehouse. I think the purpose of a cloud lakehouse is to get the best of both worlds. And the idea is to start with the cloud data lake, to source all of your data, and to do all the data preparation, and then to integrate that data to all the modern tools that people want to use. And I think the approach today, people should choose their tools. So if a BI team wants to work with Snowflake, they should get a Snowflake. And if the data science team wants an Athena, they should get an Athena. And kind of the data team's job today is to make sure that the organization can run analytics the way they want, and not according to the data warehouse that you chose, that you choose for 5 years from now for all of your use cases. It's something that we did so many years ago, and it doesn't make sense to do it today in the age of the cloud, when we have something like an Amazon S3 that I can just connect, take all of my data and feed into those databases. A critical piece to achieving that architecture is to take all the data prep and make it SQL based. So I want to give the analyst the power to go all the way to the raw data and feed that data to the engines that they use for analytics. And that's basically the concept of a lakehouse. The reason it's an open lakehouse is that you see many different engines there. It's not the same zero-sum game that the data warehouse is saying, I'm going to be a data lake as well, or the data lake is saying, I'm going to be a warehouse as well. Everyone can play together, and eventually the customer will benefit more by combining those tools instead of choosing just one. So just making sure I covered everything. This solution can be as fast to run analytics compared to a data warehouse. It will be at the cost effectiveness of data lakes, and of course you can connect everything. So it's by definition future proof. So every 3 months you can throw away one database and start using another, and that will be fine. And I think the average customer that we are seeing is using between 3 and 5 different houses on top of their lake. So instead of me describing it, let me show you a few examples. The first example here is an advertising company. That advertising company, one of the leading one in the world with app monetization, they're creating 2 million events per second with ad impressions or ad clicks, or different ad events that can help them optimize their campaign. And because it's just such a data-driven business, you have different teams in that company, and each team is using a different tool. So for example, there is a BI team that's sole responsibility is to optimize how campaigns are being run. So they want to do campaign analysis. Their tool of choice was Amazon Athena. So for Amazon Athena, we are sending data from that source in the lake in the format of Parquet, and
more competitive going forward.
If you all can just stay on mute, please.
Yeah.
We've got several.
You can also mute. Okay. So I was at Amazon Athena. Amazon Athena would run on Parquet files, but there was another data science team, and they're trying to predict what is the best, like to find the best model to predict which ad to show the user. They're using another system called Cubo, and they're using Cubo to run models. They're actually using the same copy of the data as Athena. So the data is being shared with Athena, and they're they're serving a different purpose. Then there is another team that's exposing the analytics for for those campaigns to that advertising company customers. So those customers need something that's more responsive, and they chose to use Redshift. So Redshift is getting a different portion of the data, the one that you want to connect to Tableau and see dashboard. And of course, you have the DevOps team. That DevOps team wants to analyze logs. They're using Elasticsearch. So we have 4 different targets, each target serving a different team, and each person on that team goes all the way to the raw data and gets the relevant portion that they want. As a result of using that architecture, so the alternative before was just using a data warehouse, this company is saving over $1 million per year just on AWS infrastructure costs, because each database is just getting the relevant portion of the data and not all the data, so the cost is much lower. The campaign data is available in real time, so they were able to incorporate streaming, something they couldn't do before with a data warehouse. And before, they had a data engineering bottleneck. So only 4 people in that entire organization were serving about 80 different analytics users every time there was a need. And now those 80 analytics users can go to the raw data and have that and have access on their own. So this was a very high impact project. I think today it's over a 5 petabytes per month scale, all working on the AWS cloud. Second one is a BI company. So this company has a SaaS application. They want to analyze the behavior of the different users for that SaaS application. And they wanted to build a data lake because it was 300 billion product logs, and you can't just throw 300 billion product logs to a database and expect it will work. You probably need to optimize it according to your use case. And here, because it's product analytics, the user was a product manager, a technical product manager, a person that understands SQL. So that person went all the way to the raw data on S3. They mapped that raw data to Athena, and they started doing analysis in SQL that helped them reach different insights about how their product should be used. And they created KPIs they want to monitor on an ongoing basis. So they took a BI system. In this case, it was Sisense. They used Sisense to run the dashboard. And for the dashboard, they only needed to send a very small portion of the data. And this is a much better use case for Sisense comparing to Athena. At some point, that company bought another company, which was using Snowflake to doing marketing analytics. And they wanted to continue having, first of all, have all that data in the lake and continue to work with Snowflake. So they added Snowflake as another target. And now you have one source that you can see all of your raw, and then 3 different houses for their analytics, to run their analytics. The DevOps team there is also using Elastic. I didn't put it here. So eventually I'm getting to the same 3 to 5 houses per lake architecture. The result of that project, this company is a data company, but it's not a big data company. They didn't want to spend 4 full-time employees on doing ETL. It's a very it's not the most fun work for data engineers, and data engineers are very hard to come by. So they saved 4 FTEs on ETL. They reduced the cost of Snowflake by 50% because they only sent a portion to the data to Snowflake instead of sending everything. And also the marketing data is now available in real time because we inserted the data using a streaming ingest instead of batch ingest like you usually do with Snowflake. Third example, so this is a log analytics use case. So this company is actually consists of many different subsidiaries. Each subsidiary is working on the cloud. It's quite of a security mess to manage the 16 different subsidiaries that work on AWS, and they're monitoring all the work that those subsidiaries are doing. They're working with the VPC flow logs. Those VPC flow logs were going into Splunk and only to Splunk. And because of that, first of all, the cost on Splunk was very high. The second, there was no SQL access. And the third, they couldn't really do any machine learning on it because they wanted to use different tools compared to Splunk, at least the data scientists that wanted to do that. So they, instead of sending the flow logs directly to Splunk, they send it to S3. And then they distribute it to different engines. They're sending all their data to Athena. Athena is a very low cost solution. That allowed them to save over $1 million a year on Splunk. And every time that they actually identify an anomaly, they take the time frame before and after that anomaly, they stream that information into Splunk, and they and they drill down into exactly what happened. But they don't need Splunk for everything, and it just didn't make sense with so much data. I hope that made sense. So and kind of you like the idea of the open lakehouse, and now it can help you combine the advantages of a warehouse and a lake. I actually wrote a blog about it, so you're welcome to go on Medium, search for this blog, send me questions to my email, or just connect with me on LinkedIn. And of course, we have the Q&A in a few minutes. But before that, I'm going to hand it off to Vishal and see his session for today. Vishal, we can't hear you.
I was on mute as I was told, so I was on mute. So yes, so thank you, Ori, so much. Thank you, everybody, for joining. I want to welcome you to the virtual chat on how SaaS-based ecosystems will supercharge innovation. Really, I want to talk about companies are building innovation on top of innovation from other providers and benefiting from standing on other shoulders. So my name is Vishal. I'm the co-founder and CEO of Voltex. So going into the agenda, briefly, quick tour. First is about Voltex. I will say a few words about them, about us. Then next section is about what we saw in SaaS and cloud for us, and how does it apply to the companies in general. And then second is about the specific innovation from SaaS and the cloud service providers. And the last section is about the advice to businesses we might give for the folks in attendance here based on our experiences. So yeah. So just to provide a little bit information on who we are at Voltex. So we are wholly focused on cloud network security. So think about advanced suite of network security services enterprises have got accustomed to, but delivered as a cloud native service for public cloud workloads. So our approach is discover, deploy, defend. Basically the similar idea. You cannot secure what you don't know, what you have. A lot of organizations find themselves in a situation where the distribution of control of applications, the line of businesses running their own apps, people trying to experiment, that innovation is moving very fast, very quickly. But reality is that it is happening in a very chaotic fashion. So we bring that back under the control by showing our customers, here is what you have in the cloud. The second piece is deploy a consistent set of security services and defend those apps from threat, attacks, non-compliance, et cetera, By consistent, we mean same firewall and threat policies across regions, accounts, clouds for this particular app. Now, another app might require new set of policies. So we make it achievable, customized per app, and a consistent across different clouds. Think about what we provide is a cloud interpretation as opposed to your box interpretation of network security suite of services. So now, what did we see in SaaS, in software as a service, which got us excited? So if you look at our customer base or folks who are deploying apps in the cloud, they're deploying across all clouds, heavy AWS, but still heavy Azure and GCP as well. As I mentioned earlier, there is distributed control of these applications. So different line of businesses, different departments might be deploying it in different accounts, even within AWS and even across cloud. Second piece here, when we talk to customers, is that I cannot take any more management overhead. I cannot have learning curve on something that is supposed to make my life easier. So one of the mantras we adopted was that management systems cannot have management overhead. And the other thing is that what they're doing, all stuff in the cloud is infinitely scalable, easy to integrate, DevOps friendly. this all led us to SaaS is a great way to deliver a control plane. So the question is, if you don't know, and if you don't come from a networking or network security world, what is a control plane? So think about control plane as piece of infrastructure component, whether that can be a firewall or a router or whatever, that handles the taking in of the policies as the administrator creates it and translating that to something that is consumable by, think about the old days, to hardware that did packet routing or policy evaluation or whatever. It's not just a management system. It is also how you go from sort of human understandable policy down to a machine understandable policy. So what's happened in, you might have heard about SDN, software for networking, over last decade, this idea of separating the data plane and the control plane, because the control plane had requirements for either hardware or software or access or UI and whatnot. And look, we looked at it and said, what we have got all this stuff all over the place. Enterprises are multi-cloud, but you could have all this giant control plane in the sky. And so we are SDN, or software for networking, split the data plane and control plane. And we actually said that how can we take the entire control plane and stick it in the cloud? So what we did is advantages of SaaS we used, and we delivered a SaaS-based control plane. So now, what are the downsides of SaaS or the challenges of SaaS where SaaS may not be a perfect fit? So I mentioned the control plane and how really it was a perfect fit for SaaS. But then you look at, okay, now what we call a data plane, that lower portion of the SDN style split, and that's where you actually enforce network security. And what you see in some security enterprises is, a few organizations have come out with, data planes that are also implemented as SaaS. And I think that's a great idea for certain type of applications, meaning you got users in the field and you want to secure their access to all sort of things. But the reality is, if you want to secure your applications and you're talking to an enterprise about backhauling their production application traffic to a vendor's cloud environment, that's usually met with a lot of skepticism. It's like, sorry, we are not going to do that either for performance concerns, because you got a lot of latencies induced when you get kind of a hairpin through a provider's cloud network. More likely, it's a compliance concern, which is either they have got very specific compliance requirements on the privacy front or on the regulatory front, or maybe it's just a matter of, hey, our security policy is other people don't see our traffic. So that wasn't a great fit for SaaS. So what Voltic does, as I mentioned, SDN style separation, we implemented the data plane as kind of like a software service delivered that sits in the customer cloud account. So think of this kind of an unboxed firewall or an unboxed network security service that sits in the customer account. So, after it receives the policy from the control plane, it just enforces the policy in the customer account. That traffic never leaves the customer accounts. Think about the mantra that the Voltics followed: SaaS control plane and a platform as a service data plane. So manage globally using SaaS control plane and enforce locally using a data plane which is resident in the customer accounts. So now coming back to the challenges you encounter working with the cloud service providers. And some of the challenges we found is basically that they all kind of do their own thing. They all have built their unique infrastructure for things that they prioritize, what they found most important to deliver to their customers, and they end up doing a lot of things differently. We needed to accommodate that. And so what Voltics had to do was build a custom data plane for each cloud service provider. And so each cloud gets its own uniquely adapted data plane. And then we had to do the hard work of abstraction so that in our SaaS control plane, everything appeared to be fairly uniform, versus in the data plane of each cloud, that abstraction was instantiated into that unique data plane in that unique environment. So we end up doing the hard work so it looks seamless to the customer. And that was one of the things we had to sort of accommodate in on behalf of the customers with these kind of challenges. So the key is to abstract the differences across the CSPs and give a uniform view across the SaaS control plane. So in terms of the innovations, I think the interesting part about the innovations in SaaS is that some of these innovations we wanted to both build on, and some of them we want to emulate as well, because we are delivering a SaaS service. So you look at things like scalability, accessibility, or security. These are like poster children for some of these attributes. So you look at folks like Snowflake or ServiceNow or Datadog, you look at those and we are like, those are the kind of things we wanted to do. And not only that, we used them. So you look at the product and we use these type of services. Again, we are trying to kind of emulate what they do and the benefits they bring to bear around scalability or accessibility or security. And then we do that in two ways. One, by looking at how they do it, and two, by using them. And I think that's, coming back to my earlier comment at the beginning of the session, it's really about we are standing on others' shoulders, just like, that's what technologies do. So we adopted these technologies and we emulate them wherever we can. So we provide a service which is also scalable, accessible, and of course, it is secure because we do security for the enterprises. Now, in terms of the innovations in working with the cloud service providers, again, things like scalability, accessibility, or secure infrastructure. Now, this is a bit different than the previous slide I talked about. Here, there are things that we use and that we are not necessarily emulating, but we use them heavily. So, for example, the AWS offers FPGA as a service. It became available. We adopted it and we built an instantiation of our data plane that took advantage of the advanced compute available in the cloud. So basically, we get kind of that highly specialized hardware without actually having to procure, buy that hardware. And we use the cloud service providers hardware so our customers get that data center class performance, that highly predictable performance in the cloud. Now, there are other innovations to things like object store, like S3, Azure Blob, and key management systems. And a word on that, I mean, key management for some enterprises is a highly sensitive thing. And so we looked at it and said, why reinvent the wheel and create and do our own when we could actually use the existing key management system in the cloud that the customer has already accepted and started using, and we just tie into that. So those are some of the innovations that we built on coming out of the cloud service providers. Now, working together with the SaaS and the CSPs, what are some of the benefits that the organizations might see? Our experience was this. CSPs or the cloud service providers provide infrastructure, I would say, kind of where and when you want it, and you can take it in a couple of different ways. Obviously, the geographic bit of where, what regions, what continents in all of the world. And also, when I want it tomorrow, yesterday or today, think about that. So that time dimension, but also think about in terms of availability. So if you want a certain level of service, you can engineer that to without making huge investments in data centers, building fault tolerance, and so on and so forth. Similarly, SaaS providers provide their software service basically anywhere, and kind of what you wanted and when you wanted it as well. So I want it now, I want it in the following places, they do that. So, and the advantages that this enables organizations to have is whenever their customers want it, wherever they want it, and using these two or building on these two foundations or standing on the shoulders, if I were to use the same analogy I mentioned before of cloud service providers, and the SaaS providers, you get to provide your solution anywhere your customers ask. And this is exactly what we at Voltix do too. We leverage the cloud service providers, we leverage the SaaS providers, and provide enterprise network security for cloud apps wherever they are and whenever our customers want it. Now, just a piece of advice as to specific advice, regardless of the class of to businesses, the audience who is there. So regardless of the class of apps that you might be thinking about, whether they are, pure born in the cloud native kind of applications, or they are lift and shift applications that were previously more data center model, I would encourage you to demand cloud native technologies to serve those. And the reason for that is really for cloud native applications, it's obvious, but for lift and shift applications, if they're kind of strategic or business critical applications, you don't want to anchor holding them back. And you move to the cloud for the very specific reason, even though those might be some of the previous architecture. So hamstringing those applications with non-cloud native kinds of technologies is only going to hold the organization back from gaining the benefit of the cloud, gaining the benefit of the SaaS. So, the encouragement there is to focus on technologies that is delivered and consumed as a service. So the way we think about it in the security space really is around this concept of unboxing. So the old model in security, which you get from your traditional security companies, you get these appliances, you rack and stack them, whether they were hardware or virtual, your unit of management was a box. And when you start thinking about things that are delivered as a service, you move from, I always like to talk about moving from a box-based to a service-based kind of mentality, where scale and change is sort of just assumed. Now, the ability for that service to adapt to changes is also assumed. So that results in cloud outcomes, like the technology outcomes, giving you the operational simplicity, all the mundane stuff like scaling and changing is sort of automated, is resilient, it's always available, and back to where and when that's I was mentioning before. It's whenever you want it and wherever you want it, it's available. Sort of that auto scalability in all sort of cloud technology outcomes. And the more important that is the business outcome, and they are more important, which that the biggest one is shortening the time to market on the new capabilities. So if you can deliver a service, if you consume services, then you can deliver your services, your capabilities faster than your competition. And that's, a competitive advantage at worst and outright margin at the best. So furthermore, there's another business outcome, which is basically based on the consumption-based cost, which is to say you only pay for what you use. You don't have to pay a big upfront cost that will hopefully repay at some point. You pay as you grow. So it's obviously a very highly desirable business outcome as well if you rely on SaaS and the CSPs together. So that's pretty much the advice we give to the businesses, to the folks here in the room. And we took the same principles and built a service to deliver network security. So yeah, that's pretty much of course, thank you. You can email me for any questions at my email. You can follow me on LinkedIn. Yeah, I will now stop sharing and we'll have the Q&A to both me and Ori.
Excellent. Well, yes, thank you, Ori and Vishal. I think great ROI examples, Ori, you shared on time savings and decrease in costs. And then Vishal, loved the examples that you went through and how you really showed where you can do a lot more and the benefits with working with the cloud service providers. So thank you. Want to turn it over to anyone who has questions now as well. So just a reminder, if you do have a question, unmute, but please do ask our guests anything from the content they shared.
And if you're shy, you can type in your question and we can ask for you. But, you know, while people are thinking of questions, let me throw something out there for both Ori and Vishal. You know, first of all, I think, you know, Leah, yes, great examples of ROI, but what I also noticed was the amount of interdependence on the ecosystem. So each of you brought up all of these, you know, different ISVs, different providers that you either have an integration with or are working with. So it just, you know, shows the value of the ecosystem, and it really takes a village to have a successful cloud-based SaaS product. Couple of the things that I, you know, just from my experience, things that tend to cause hiccups or, you know, question marks from an operational perspective are things like pricing and, you know, SOC 2 certification. Those are two things that, you know, definitely are a lot harder than they may seem. So how did you guys, you know, approach pricing your product? And then also, how did you get the team aligned, or how did you, you know, for something like SOC 2, where you have to be SOC 2 certified in order to sell into certain industries, how did you incorporate that into your planning, your product process?
Okay, Sandhya, I can take that.
Sure.
Yeah, so second thing on the SOC 2 and the compliance. So if you saw my talk, right, it's very important that we built our service such that our control plane or the policy plane is a SaaS. And we do the SOC 2 compliance for that. But if you know, our data plane, as I mentioned about, SaaS is like great, but it may not be desirable for everything. For example, the enterprises don't really want their traffic to be coming out to a SaaS vendor, right? So we did a split, and we built a data plane which runs in the customer account. So traffic stays there. So we didn't have to worry about the compliance like SOC 2, HIPAA, high trust, PCI, because our data plane, the keys, they all stay in the customer account, but we had to go over certifications for our control plane. So that helped us reduce some of the work we have to do. So the customer key data and the logs are not really kept in with us. And on the pricing is like beautiful because it's based on the consumption. So for example, the way we do in Vaultix is like, unlike the traditional box vendors, which give like virtual appliances in the cloud, you kind of get like bulk licenses and you say, okay, I want 10 firewalls, and you pay them forever. In our case, we kind of every minute, because of the SaaS controller, we know how many firewalls they're using at a given instant across their entire cloud, entire accounts. And then we average that out, and then they pay for what they use. So pretty much a very neat model. And I believe over time, even the pricing wise, even we use the cloud providers as well. We use SaaS services. I think over time, it's cheaper to use these as opposed to just take the box-based approaches. That's about our experience.
Lee, I think that this is a very good point. I think that we felt that when we were in early stages where customers didn't want to even have a conversation with us about access to data. So either install the software locally or figure out a way that you don't have access to the data. The cloud lets you do something that we didn't really have for on-premise, is to manage infrastructure in the customer's account, but don't have access to their data. So it's a zero trust system in which they get something that's fully managed, but they don't need to trust the vendor. It was a big accelerator of our go-to-market. And once GDPR and CCPA kind of kicked in, it became almost impossible to sell the old way. I think that one thing that I want to add to the technology side, the business side is also interesting because we are doing most of our sales today through the AWS marketplace. So the customer can pay for Upsolver from the AWS budget they already have, instead of, open a vendor and do like the entire long process that both sides don't need to do. So you're getting both the technical side and the business side of just selling faster and then selling for less money as a result.
Excellent. No, great answers and great questions, Cynthia. Any other questions out there? So this is September, and I think now's about the time of year that we start seeing a lot of, in the news, if you will, the 2021 predictions, right? So I want to read two from 2019 that were predictions for 2020 on SaaS, and then it would be great to hear both Ori and Vishal what is your one or two predictions for 2021. So one was 100% SaaS companies will no longer be an outlier. And then another one I recently saw last year for 2020 was that the new role of the CIO is in the age of productivity. So as more companies standardize on SaaS, IT will continue to evolve more for a proactive business partner versus a reactive service provider. So those are two predictions from 2019 for 2020. I think we definitely saw some of that. What are your predictions
For 2021?
For 2021.
Well, putting me on the spot there. I think, so of course I'm taking it more to data. I think that if we had Data Lake 1.0, which was Hadoop, and Data Lake 2.0, which was cloud, I think Data Lake 3.0 would be all the users starting to get access on their own to data, and that means that we'll see the big change in the complexity. So everything would be simpler, and not just the experts would own the cloud and the big data and all of that. You'll see it going into different departments that want to own all of their solution and not be dependent on IT. So eventually, the cloud brought us into faster IT, but it makes sense that it's just going to be self-serve IT. And I think we are already seeing it, but I think that this would be a prediction I would put for 2021. To Vishal.
No,
Yeah.
Thank you, Ori. Yeah, I think I was put on a spot too. So I will take it back to what we do on the network security side. So we see that the enterprises are going to the cloud. And one thing is, if you see today's world, a lot of the traditional vendors, they still bring their what we call the boxes and the appliances. But if you see in the cloud, applications, infrastructures, data lakes, load balancers, warehousing, everything is delivered and consumed as a service. So everything is going at almost 100 miles per hour. The network security from the traditional vendors is all box-based, and basically it becomes at 5 miles per hour. So my prediction is that the enterprises will demand that everything they consume in the cloud be a service. And service is not just based on the pricing or on the consumption model. It's about the fact that they want to use the service as opposed to trying to make it operational, trying to scale it, trying to make it fault tolerant. So all that, they should leave it to the vendor, and they want to consume services so that they can really get the advantages of the cloud. Because today, a lot of the enterprises are getting bogged down by this weakest link, I call them, and they don't get the full cloud advantages. And I think cloud next year we'll see a bigger growth. And when this happens, you will see even more enterprises going to cloud and gaining more from the cloud and SaaS.
Yeah, great predictions. Ori, I think it's what do they say? You can never go wrong with data, right? Data is very key and critical. And then Vishal, to your point, yeah, the as a service, I think certainly this pandemic has driven a lot more the digital transformation and as a service business model. So we'll be curious to see what your predictions pan out in 2021. Before we wrap up again, any other questions out there from anyone?
I have a question for Ori. This is Michael Cuneo. So first of all, thanks both to Ori and Vishal. Those were really interesting talks. Ori, what is your company's relationship with the ecosystem as it was described on your side? So the Snowflakes, the Splunks, the Elastics. People, those vendors aspire to own data, and they're increasingly, enhancing customers' utilization of the data. Snowflake has these data fabrics and marketplaces where you can, merge sets and essentially rent your data out to other people even. You guys seem like you're optimizing for S3 being the source of all data, and also, lowering the costs, as you pointed out, on those applications that consume the data. So do you have are you guys frenemies with your customers, or not your customers, but the applications that you optimize, or what's that dynamic like?
Yeah, I guess that's some kind of definition. So we have connectors to all of them, and we often recommend many of them according to the use case. So the customer tells us. I just wouldn't want any of them to own everything. I think that's kind of Upsolver's point of view. So think about like the amount of databases that you use today compared to the amount of databases you used 10 years ago. And I think it's inevitable that databases are going to turn into query engines, and then everything else will be centralized. So storage will be centralized on S3, metadata will be centralized, which we are already seeing with tools like Glue Catalog, access control, which we are seeing with services like Lake Formation, because you don't want to do the same work in every database. It's a nightmare. So I think that right now we are kind of in a transition period where databases are still databases and query engines are innovations, but that's something that's going to change. And the approach of pluggable query engines is what, let's say, what I believe, what the thing that people in Upsolver believe in, and that's kind of how we're trying to think about it. I don't think we are frenemies. I think that if you're expecting, like if I would be a person in Snowflake expecting that all of the customer data should only be with me, that I'm not looking at the customer's best interest. And the customer's best interest is to solve every use case in the best way, and it's simply not reasonable to think that one database would do everything. And I'm saying that as a Snowflake fan. So I wouldn't say it's frenemies. I think we are both aligned on the customer interest eventually.
And do you build the connectors, or do the partners, or who builds them, and what are they? Are they like parsers, or are they?
No, so they're actually, you can think of them as ingest connectors. So Upsolver connects to sources like Kafka, Kinesis, S3, create a data lake on S3, and then makes it, I don't know to say easy or simple, to kind of transform the data and push it into Snowflake. So our connectors create a table, change a table, replace data from the lake into Snowflake. Same goes for Athena and the others.
Okay. Last question. Do you do anything that's not SQL?
Yeah, so it's actually a visual UI and SQL, and it's bi-directional, so you can work from one and it will change the other. And that SQL is extensible with Python, so you won't be locked to our language.
Okay, thanks.
Sure, thank you. Good questions.
They were, and I know we had our member from Snowflake on earlier, so I think she did appreciate that you both mentioned the work you are doing with Snowflake. I think we are coming to the top of the hour, and we had great questions, great discussion again. I want to thank Vishal and Ori and everyone who joined for this great session. And we will get the recording out and edit after it's edited for further posting and for anyone who wants to revisit or who missed it. In the meantime, you all know where to find both Ori and Vishal, or reach out if you'd like us to connect you to them. But thank you, everybody, and to our guests, and to Dominic as well for introducing us to both these companies.
Great.
Thank you, everybody.
Thank you, everybody.
Thanks, everyone.
Thank you.
Thank you.
Bye.